A small one, not very powerful, just magnitude 1.8, but it's enough to scare the population, you know, and make them run outside their houses. Little did they know that it was the first of many earthquakes that over the next few months led to the 6th of April 2009, where when in the middle of the night, 3:32 a.m. in the morning, an earthquake of magnitude 6.1 hits the city, completely destroying it. 309 people died that night. Around 1,600 people were wounded, and damages were estimated in around 10 billion euros. A real tragedy. When events like this happen, especially with earthquakes, the question always comes up: could we have predicted it? Can we predict earthquakes? And seismology is very clear. The clear answer is no, we cannot predict earthquakes. If by predicting we mean doing a deterministic prediction, as in knowing the date, the intensity, and the exact place where the earthquake is going to strike, we cannot know these things in advance. What we can do, however, is quite easily, we can do a probabilistic prediction of earthquakes, because they follow quite stable statistical patterns. For example, at L'Aquila, they knew that an earthquake of magnitude at least 6, so 6 or over, an earthquake of magnitude 6 or over hits the area around every 300 years. They had an earthquake like that in the 1400s, in the 1700s, and now in 2009, unfortunately. So at L'Aquila, they knew that in the next 10 to 50 years, an earthquake of magnitude at least 6 was going to strike. What do you do with that information? Of course, you can't evacuate the population for 50 years. You can, however, plan for scenarios. You can do risk management and talk about options and what you could do if the earthquake were to strike. Now, there are two very interesting attempts at predicting this earthquake that you'll see make a really good metaphor for what I'm going to show you in this presentation. The first attempt was made by, I'm going to call him a pseudo-scientist, an amateur, almost scientist, who just the next day, the day after the earthquake, claimed that he had predicted it, but that the authorities had forbidden him from giving the alarm. Later on, this turned out to be false. He didn't do any of that. But the media picked up on the story and turned this person into some sort of hero, saying that if only we had listened to him, we could have saved all these lives. So this was the first interesting attempt at prediction. The fake expert that is turned into a hero because he promised certainty. The second attempt instead was made by the Italian government, which in the weeks before April had put together a special task force of experts and scientists, asking them to look into the possibility that a catastrophic event was about to happen. And just a few weeks before the final earthquake, these scientists told the population, look, what's happening can be considered normal for this area, but there is the risk that a strong earthquake could happen. So we could maybe, talk about options, plan our strategy. Of course, people only heard the first part, which was, oh, this is normal, and did nothing. And then the earthquake happened. And after the earthquake, these scientists were put on trial. One of them even went to prison with the accusation of having failed to predict the earthquake. So second attempt, the real experts explain what scenarios could and couldn't happen, and they're put on trial because of that. And this is a great metaphor for two important lessons that I've learned in the last few years working with teams that use data to make their predictions. The first one is that when we're dealing with uncertain events like earthquakes or software projects, a forecast will almost always beat an estimate. We need to learn how to think probabilistically and do forecasts instead of keep doing our usual estimates, which are a deterministic approach. We need to stop listening to these fake experts that promise us certainty and start listening to the real experts that tell us what could and can't happen. But to do that, we need to improve the way we communicate our predictions. Forecasting is all about communication. We need to learn how to express our predictions, to communicate options and risks, and beat our bias for certainty. And in this presentation, I have plenty of examples of how I do this in real life conversations. My name is Mattia Battiston. I'm originally from a small town in Italy called Verona. It's the home of Romeo and Juliet, lovely place. I've lived in London now for 7 years, even though I still can't shake my Italian accent. I'm mainly an engineering manager working for Tesco at the moment. We are very busy trying to keep the population fed. It's a very interesting time. And if you like any of what I'm talking about today, I'm co-authoring this little book called The Team Guide to Metrics for Business Decisions. So if you want to know more about what I'm presenting tonight, you can get this book with a 20% discount using this link. Don't worry, I'm going to post the link on the meetup page as soon as I finish here. Most of the teams that we work with, pretty much every single team at some point or another has to answer these questions. How long is this going to take? What can we achieve in this amount of time? Can we hit this particular deadline? And the typical answer in agile teams looks something like this. We get our planning poker cards, we use story points. And this is what the first team that I joined when I moved to the UK was doing. And this data is from that team. That team was struggling with predictability. Stakeholders were complaining that the team wasn't predictable, that were making promises they never kept. So for a while, we started tracking some data. And we were tracking what we call lead time. So how long does a story take from start to end? And we did this chart. This shows story points down on the x-axis and lead time here. So these blue dots, each blue dot is a story, and it's showing me that this will be a story of 1 point. Stories of 1 point were taken from 2 days to 10 days. And stories of 2 points were taken from 2 days to 20 days. Stories of 3 points were taken from 6 days to 18 days. There was really low correlation between our predictions, our story points, and the actual lead time of stories, the actual time that something would take. And over the last few years, lots and lots of teams are finding similar results. Our estimates very rarely correlate to how long things actually take. And there are 3 important reasons why this is the case. Oh yeah, by the way, if you want to do this experiment with your own data, at this link, you can download some spreadsheets that we're publishing with the book, completely free, and you can put your own data in the spreadsheet, and it will tell you how much your story points come close to how long things actually take. 3 reasons why our estimates are often so wrong. And the first one is that very few teams limit their work in progress. We are used to work with a really high amount of work in progress. And this is a great metaphor that I stole from Troy McGinnis. Our process almost always looks like this, like a road that is so busy that the size of the work stops mattering, because it doesn't matter if you're a bicycle, a car, you could even be a Ferrari, it doesn't matter, you all move at the same speed, which is very, very slowly. The second reason is that in all of our processes, there are many queues. There are some states represented here in green where people are actually working on a story, doing something on a story, but also many states that are just queues. The story is there waiting for something to happen, like waiting for someone to be available, waiting for the next release, waiting to get information from someone. And if you look at the percentage of time that a story spends in the green states compared to the red states, we call this metric flow efficiency, and it's reported to usually be as low as 5 to 15%. So in a normal team, it's very common that only 5 to 15% of the time of a story is spent actually working on the story. The rest of the time, the story is just waiting or going through your process, which is shocking. But this explains why when we estimate, when we are asked for an estimate, our brain automatically thinks, how long will I have to work on this thing? But in doing that, you're only thinking about these green states when you're actually working on something, ignoring the majority of time which is going to be spent in queues. And the third reason is, of course, that there are lots and lots of unexpected events that happen on a daily basis. And depending on how complex your scenario is, these can completely invalidate any sort of plan or estimate that you make. For these reasons, the teams I work with and more and more teams everywhere in the community are coming to this conclusion that the only size of a story that matters is small enough. I coach teams to do as long as they do a conscious effort into splitting their stories as small as possible, and they use some consistent criteria for breaking down their stories, then the actual size of the story, the actual number of story points on a story, it doesn't matter anymore. The only size becomes small enough. So we still get the team together. We have those conversations to do, to break down a requirement and do story slicing. But then as long as the team agrees that this story is small enough and can't be broken down any further, that's enough. That's enough to stop putting story points, stop doing the estimates that we usually do, and instead using data and forecasting techniques that I'm about to show you. And just to answer a very common question that I always get, I do not mean the stories need to be the same size. It's a common myth. You don't need stories to be the same size. As I said, as long as the team is making an effort to split them as small as they can, there will be some natural variation in size of the story, but this will naturally be accounted in the data that you use, and I'm going to show you how. If you want to do this, what data do you need and how much? You need a lot less than you think. It's very common to think that you need hundreds of samples to do something like this, but really all you need to capture is, at the very minimum, just capture the start date and the end date of a story. As long as you have these two dates, you can calculate the lead time of a story and you can do everything that I'm about to show you. And 5 to 11 samples really are enough to get started. Even with 5 samples, it's enough to put you in the right ballpark. And then of course, as you get to closer to 11, with 11 samples, you've got something like 90% confidence in your predictions. And then of course, the more samples you add to your data set, the more precise your predictions will become. But really 5, 7 samples up to 11 is really enough to get you started. And then of course, if you've got the chance, capture a bit of extra information that will help you analyze the data later on. But start and end dates are enough to do everything that I'm about to show you. In some teams that use physical boards, it's so easy that I just record these things manually on the post-it notes that the team uses for cards. But with electronic tools, you can pretty easily extract this data from whatever tool you're using. And my recommendation is still that as you're starting with these approaches, as you're learning how to work with data, use some spreadsheets to start with. And we've open sourced a lot of them. Troy McGinnis is a big expert in this area. He's open sourced a lot of spreadsheets that can help you. Play around with some spreadsheets to start with. And then once you know what you're doing, what you're looking for, there are some tools that are starting to be mature enough to be used and that you can usually plug into what you're already using. I can see things in chat, but I'm just gonna look at questions at the end if that's okay. Corrado, if there's anything urgent, feel free to jump in.
Yeah, I manage the chat, don't worry.
Cool, thanks. Right. The first metric I want to talk about is lead time, which a lot of people might call cycle time, lead time. Depending on who you talk to in the community, they will use a different term, but they mean, as long as you're clear about what you mean by lead time, it's fine. And what I mean by lead time is how long a piece of work takes from start to end. Now, the trick is defining where the start and end is. The starting point of your lead time is what in the Kanban community we call commitment point. So there is usually a point in your process where a story is picked from a backlog and it becomes the next thing that you're going to work on. That's when your lead time starts. And the end, again, that depends on when you consider that particular story done. In this team, we had some stories for which we were doing continuous delivery, so they could go all the way to done, released in production. But other stories were following more of a Scrum type of release, released every 2 weeks. So they would wait here for a couple of weeks. So the lead time for those stories was only this one. So that's just an example to say that sometimes you need to segment your data depending on a different process that you might follow for different types of work. But lead time is how long does something take from start to end. And once you have the data, we can calculate this really interesting metric called lead time distribution, which is basically a histogram of your lead times. At the bottom here, we've got all the possible lead times that have happened in the past. And here we are counting how many stories have taken so long in the past. So 7 stories took 1 day, 8 stories took 2 days, 3 stories took 3 days, and so on. Very often you will find a shape that looks like this. This is called a Weibull distribution, but don't worry about that. It's much easier to understand if we look at this data on the right. Because I know how many stories have taken how long, we can express that as a percentage. And so I can tell you that in this team in the past, 13% of the stories have taken 1 day, and 15% of the stories have taken 2 days, and so on. Now, you sum those up cumulatively, and you get what is basically a percentile. And this number here tells me that 52% of the stories in the past have taken 4 days or less. And 88% of the stories have taken 9 days or less. And this is really powerful data for having conversations with the business, having business conversations. Here is a very common example. Someone comes to the team and asks this common question: how long will this story take? What I do is I go back to that data and I look for this, this first green line. This is the first line where I have a high confidence in my prediction. And this line is telling me again that in the past, 88% of our stories have taken 9 days or less, so have been completed in a maximum of 9 days. And that's what I reply, that's what I say. We are 80% confident that it won't take longer than 9 days. Now, it might take just 4 days, but bear in mind there's only a 50% chance, so I wouldn't make any promises on that. And this is a key, right? I'm not gonna say 4 days so that someone will take that as a promise, as a commitment, without knowing what would be the impact if we said 4 days and then it turned out to be wrong. So you see, we start to talk about the risk of being wrong and the impact to the business if we don't complete this in the number of days that we said. And we also say that in the worst case scenario, we might need 10 days, but there's only 10% chance that this might happen. And now we can talk about the impact of this. So if the story did end up taking 10 days, what would be the impact to the business? Would this story still be valuable? So we are changing the conversation from focusing on the estimate to talking about risks, scenarios, and the value of the story. Another real life example, this was with a team in the telecoms domain, and we were doing this piece of software that basically when you ring up a call center saying my internet doesn't work, they would use this software to analyze what was wrong on your phone line and figure out what the problem was. A bit of a legacy software, only released monthly, and 4 days before the next scheduled release, the managers of the call centers come to us and ask us this question. The next scheduled release is in 4 days, and they wanted this new feature done that would help them analyze this new problem that they were experiencing. So they wanted to know if this story was going to be ready in time, because if it was going to be part of the release, they needed to explain to the people in the call center how to use this new feature, change the scripts that they used to talk to customers about this problem that they could experience. So we went back to our data again, and our data shows that only in around 50% of the scenarios, 50% of the times, a story is completed in 4 days. And so our answer was something like this: we're only 50% confident that we can make it. What do you want us to do then? And they replied, never mind, we'll wait for the next release, and thanks for the honesty. They didn't want to risk explaining this new feature to their team if the feature wasn't going to be in the release, because it would have caused more confusion than it was worth it. The team, by the way, started working on it anyway, but we hid the feature under a feature flag, and indeed it wasn't ready in time, so we simply left it turned off and we released anyway. And the feature was then ready the next time, in a month's time. I'm going to skip this example because cool. The second metric that I want to show you is called throughput, which some people call it delivery rate, or even simply story count, because that's what it is. It's a count of how many stories does the team complete in a period of time. And very, very commonly, that period of time is a sprint. So we are simply counting how many stories the team completes in a sprint. So the team completed 8 stories in sprint 15, 12 stories in sprint 14, and so on. You just count how many stories the team is completing in that period of time. And having that data, we can calculate some stats that are very useful, but without getting too bogged down in the maths behind it, I'm going to show you how I use these stats. And once again, we got some spreadsheets that you can use for free if you want to play around with these things. Let's say that we're trying to answer this question: how many stories can we complete in the next sprint? Typical question for a sprint planning or a queue replenishment meeting. How much work can we do in the next sprint? We go back to our data and look at these 2 numbers down here. This bottom one is telling me that in the past, in this team, in 80% of the sprints, the team has completed at least 5 stories. And this other number is telling me that in 50% of the sprints, the team has achieved up to 8 stories. So I know that the team is going to complete somewhere around 5 to 8 stories. And that's what we answer. We are 80% confident that we can complete at least 5 stories. We might get up to 8, but there's only a 50% chance. So, you know, we can make a strong commitment to the first 5 stories, but a maybe to these other 3 stories. So let's not make such a big, strong promise on those 3 ones. And a great way, really powerful way to visualize these predictions is with this technique called rolling wave forecasting. Basically, if you got your backlog in a prioritized order, the trick is that next to the backlog, next to each story, we visualize how confident do we feel that this story is going to be completed in the next 2 weeks. So these top 3 stories, we have over 80% confidence. So we are saying they're definitely going to be in there in the next 2 weeks. Probably these 3 other stories, possibly these 2, and the 9th is very unlikely. And this is based on our confidence levels taken from the data that I've just shown you. And this is an extremely powerful tool for our stakeholders, because at any point they can rearrange the order of the stories and change priority orders based on how confident they need to feel that something is going to make the cut in 2 weeks. Really powerful tool. Another example of using Throughput. My product owner or manager or someone wants us to complete 10 stories in the next sprint. Can we do it? We go back to our data, and my data is showing me that only in 25% of the sprints in the past, we've completed 10 stories. So there is a chance we might do it, but it's quite a low chance. It's only a 1 in 4 chance. So we answer like this: we only have 25% confidence. Are we willing to take such a high risk? And what is the impact of being wrong? This is a very important question. What is the impact of being wrong? What if we say yes to these 10 stories and then we don't achieve them? What happens? You know, it's so common in a situation like this for the team to feel under pressure, the pressure to say yes, to just say, yeah, we're gonna try. And then the team ends up working overnight, cutting corners and taking just poor decisions that affect us in the long term. But because we use data instead in this example, it's much easier to stay true to what the team can realistically achieve and set realistic expectations. And this leads to what we call forecasting, when we get to answer really difficult questions like this. How long will this project take? So far we talked about how long does a story take, how much can we achieve in a sprint. But when we get to a bigger scope, how long will this project or feature take? How do we answer that? A lot of teams struggled with this. And the way that I answer this question is with using a technique called probabilistic forecasting, which is a scary fancy term for something that is actually quite easy. I'm going to show you how you do it. But basically, the trick is that you use your historical data to simulate what might happen in the future. And then you express the results as a list of possible outcomes with the probability that that outcome could become reality. It's a fancy term for a spreadsheet. And I'm going to show you how it works. A spreadsheet, which of course you can download and play with if you want to try any of this. Here's what you need in input. Let's start on the right side, which is the easier part. We need in input the throughput that the team has had in the past. So in this example data, this is actually data taken from a real team that I was working with. This is the number of stories that the team has completed in the last 11 sprints. 2 stories in the first sprint, 5 stories in the second sprint, and so on. So on the right side, past throughput of the team. And on this side, we need an input, the amount of work. So we would do the usual meetings to break down our requirement into epics and stories. And let's say that the team has identified 25 stories that need to be done for this project. Now, on top of those 25 stories, we need to account for a few things that are going to happen. One is that over the course of the project, we're going to have bugs, we're going to have problems that will give us extra work. And here I'm pretending that this team, based on historical data, usually finds 1 bug every 10 stories. And then we need to account for the fact that as we work on this project, we are always going to find new work that we haven't thought about, or we realize that a story wasn't quite broken down small enough, so we break it down into smaller stories. So this is to say that those 25 stories that we initially identified over the course of the project will probably turn out to be 35, 40, even 50 stories potentially. Having those things in input, we run our Monte Carlo simulation, which again is a fancy term for something really simple. Here is how it works. In this example, we are pretending that we've broken down the amount of work into 20 stories. And we want to know how long it's going to take for this team to complete those 20 stories. So here's what we do. We go back, so I'm going back to a slide before. We go back to our past throughput and we pick a random sample from our past throughput. We just pick a random. And in this example, I picked the number 3. And that's pretending that in the first sprint, the team is going to complete 3 stories, leaving 17 stories remaining to complete. Simulate the second sprint. We pick another random sample. In this case, I got 5. And that means that after the second sprint in our simulation, this team has completed 8 stories, leaving a total of 12 stories to complete. We carry on until after 5 sprints, we've completed 21 stories, therefore completing the 20 stories that we wanted to complete. So in this first simulation, the team took 5 sprints to complete the 20 stories in input. And then the trick of a Monte Carlo simulation is that you repeat this little thing for a few thousand times, something like 10,000 times. And in some simulation, you might get 4 sprints, some might be 7 sprints. You get a variety of results. And then you express these results as a list of probabilities. So in 1% of the simulations, the team only took 2 sprints to complete the amount of work. And in 17% of the simulations, it took 3 sprints and so on. And then you put this together cumulatively again, and you get that we're in 85% of the simulations, the amount of work was completed in 5 sprints or less. And that's how we answer. How long will this project take? We say, we have about 50% chance of completing the work in 4 sprints, but we are 85% confident that it won't take longer than 5. So it's going to land somewhere between 4 and 5 sprints. Now, we need to warn you that in the worst case scenario, we might need 6 sprints, but there's only a 15% chance that this might happen. What will be the impact of that? So again, we're talking about risks here and the impact of something going wrong. What if an earthquake happens in this project and we end up taking 6 sprints instead of the 4 or 5 that we forecasted? Would this project still be valuable? What will we do? And here comes the even more powerful part. We will review our forecast after each sprint. So this is the forecast we're giving you at the beginning of the project, but we will keep updating this forecast and giving you an updated forecast continuously over the course of the project. And that's doing something that we call continuous forecasting. This is a spreadsheet that I was using for doing that. And it's something that I would update at the end of every sprint and send out to my stakeholders with an update. This was for a project, again, in the telecoms domain. It was basically around November time, Ofcom comes out with a new piece of regulation to force broadband providers to basically, they couldn't lie to you anymore about the broadband speed that you were gonna get. They couldn't tell you anymore, you're gonna get up to 20 meg, and then you never do. They were actually being forced by the end of March to give you realistic predictions of your broadband speed. So new regulation to implement by the end of March, hard deadline. If we didn't hit it, we would get millions of pounds of fine. And this is what we do. At the beginning of the project, we broke down what needed to be done. And so how many stories are left? We found 10 stories to do for this project. It was November time. We were in a sprint that we were referring to as sprint 333. And we ran our simulation, which told us that we were over 90% confident that it will take us 5 sprints to complete those 10 stories. Therefore, the answer to when will it be done was in sprint 338. And we visualized that on this side here with this burn-up chart, where the top line is the size of the backlog. And then in yellow, we have an optimistic forecast with only 50% confidence. And then in green, a pessimistic forecast, but more realistic with high confidence, which was the 5 sprints. And so the team set out to work. After 1 sprint, here is what happened. The team had completed 3 stories, but the amount of stories left, instead of going down, had gone up from 10 to 13. If you look at the size of the backlog, it had gone up. And that's because, as I said, as soon as you start working on something, you realize that there are things that you hadn't thought about. There are stories that were broken down too big and you need to split them up. So this is a very, very common occurrence. As soon as you start working on something, you will find new work. And you see, at the end of the sprint, we immediately update our forecast. It was now forecasting to complete in sprint 340, which was still in time for March. Another sprint, boom. The team kept delivering quite consistently. It was even completing more than usual. And still the size of the backlog kept growing as we were doing demos to our stakeholders and showing them things. They kept adding to the scope and we kept finding requirements that haven't been mentioned before. And at this point, the forecast now tells us that we would only complete the work in sprint 344, which was past the deadline. So at this point, it was, raise alarms, call all the stakeholders. We needed to do something to manage this project and bring it back to something that would allow us to hit that deadline of end of March. And we did. We talked very calmly with the stakeholders, made plans, talked about options. And so we managed to bring down the scope a little bit, but in that remaining 15 stories of scope, we also identified what was part of the MVP that had to be absolutely done by the end of March. And we identified some other things that we could automate later on just to make things better. After a few more sprints, that was the end of March when we completed the MVP. The MVP was in production in a bit of a hacky way that required a bit of manual intervention, but it was enough to make Ofcom happy, fulfill the requirement, and then the team was able to take a little break and work on something else. And then we completed the remaining scope of the project in sprint 343, taking a total of 10 sprints, which our forecast predicted from the second sprint, actually. Now, if I were a project manager or someone in a similar role and looked at this project, I would probably call this a disaster, because you look at the scope that kept growing and growing and growing. But actually, having been part of that project, I can tell you that this was one of the most agile projects I've ever taken part of, because at any point in time, I could give predictions to my stakeholders and talk about how to manage the scope, whether this spike in scope was to be allowed in or not. And it was a true collaboration between the team and the stakeholders. I'm going to skip some other examples to leave more time for questions. So if you like what I'm talking about and you would like to try, how do you get started? My advice is always to keep doing what you're doing. Don't change anything drastic to start with, but at the same time, start collecting some data. So follow your process as you do right now, but start collecting some data. And the next time you have to estimate something, do your estimate as usual, but also use some of these spreadsheets to run a forecast. And then as your project unfolds, keep updating your forecast with new data. And at the end of your project, see what happened. What did your estimate say? What did your forecast say? Which one proved to be more useful? Usually the forecast comes a lot closer to reality, and that is a strong argument that could help you convince your team and the people around you to change your approach. In summary, these are the 2 lessons that I tried to share with you tonight. First one is that when we deal with uncertain events like earthquakes or software projects, a forecast will almost always beat an estimate. But to make that work, we need great communication. We need to learn how to communicate our predictions and talk about options and risks. That's it from me. Thank you very much. Right, this is when I would take questions. So I guess I'm gonna look in the chat, Corrado. There's a lot of messages though. I don't know if you want to help me out and tell me if there was any particular question, or if people want to unmute themselves and just ask, that's great as well.
Sorry, Mattia, I was offline for a few minutes.
No problem.
Because of the network issues at home. Sorry.
Oh yeah, that's a classic these days.
No, but I see that you are continuing the event, so you didn't realize that I was disconnected. I see everybody is connected, so that's fine. No, not a problem, not a problem. So now we are having the Q&A session.
Yeah, so there's a lot of stuff going on in the chat. I'm not quite sure how to manage this. Okay, I don't know. I'm gonna pick the questions that I can spot. Let's see. Going from the bottom, because why not? Don't the size of the stories bring a lot of bias to all these metrics, especially difference in sizes between stories? All right, to a certain extent. So, as I was saying, let me go back actually to a previous slide so I can show you exactly what I mean. See, we don't need to stress too much, trying to make stories a similar size. As long as the team tries to break them down as small as possible, then stories will naturally have a variation in how long they take. And we know exactly what that variation looks like. It's going to be following this type of shape. And we have data that tells us what that variation looks like. Oh, where did that go? Where is my chat now? The bias on these metrics, to a certain extent, it's kind of intentional that we're biasing the team towards smaller stories, which is actually a really powerful side effect of this, because smaller stories have a lot of benefits. They improve your flow, they deliver value quicker, you get feedback quicker. So I think I would say, yes, there is some bias, but that's intentionally producing a positive side effect in the team. I hope that answers your question. Story numbers versus story points. How can you manage this? I might need you to expand on that. So as I showed you, the story points tend to have very low correlation with how long things actually take. So what we do is simply calculate the throughput, count the number of stories. We still have all the meetings, when we get the team together and talk about the requirements and decide how to break it down into epics and stories. But that's where we stop. We just skip the last part of trying to put numbers on them. The only question on a story becomes, can it be any smaller? Let me know if you want me to clarify. Hi, what data would we collect? Aha. Good job, I had it in my slides. As I was saying, to do what I showed in this presentation, it's enough to get the start and end date of a story. So as long as you know what date a story started and what date it finished, that's enough to calculate the lead time of that story and to know in what sprint the story finished. So you can calculate lead time and throughput, and that's enough data to do all the forecasting that I was showing. And 5 to 11 samples is enough to give you enough enough accuracy. For projects with fixed scope and timelines, example, regulatory projects, what's the benefit of using Scrum over traditional waterfall approach? Oh, wow. How long have we got? Can I play my jolly card and ask Corrado for some help here? Because it's more of a generic agile question.
Yeah, obviously, if you are fixing scope and time and obviously resources, it's not the best way to start an agile thinking and agile way of working. So let's leave at least one of these variables open, and so we can discuss. Okay?
Indeed, yeah.
It's
what
called
book?
the iron triangles, if you want to look on the web, Google on the web.
Yep, that's a classic. What books are you reading? Well, lucky for you, I've included a lot of books that I would recommend down here, which are great if you want to know more about metrics. I will publish these slides on the meetup page later on, by the way, so you can get all of this. Number of tickets doesn't account for the size on its own is not useful. Well, yes, and that's by design. It doesn't account for the size because we've made an effort to make stories as small as possible. So as we were saying, they will follow a natural variation in size.
Yeah, Mattia, there was a question in the list saying that, are you considering the lead time from DOR or from when the story has its own first inception, let me say, when you have the idea of the story?
In terms of, all right, I'm gonna say it depends on what you're trying to predict. Usually, we are trying to make a prediction or an estimate about how long the team is going to need to, how long will the team take to deliver this. So we're talking about the last delivery part, the implementation part. And for this sort of predictions, what matters is the part from the definition of ready, as the question was. So from when a story starts implementation to when the story is finished. Some teams also find it useful to gather the data of from when a story is first created to when it finishes. But as long as you keep the data separate, then you can make comparisons and look at the amount of time that a story spent in the backlog before finally being picked up by the team and then delivered. That tends to be a lot more unpredictable because things could stay in a backlog for weeks, months, even years, for all we know, depending on the priority, the value of a story. So usually it's really hard to make predictions on that because of how we manage our backlogs. So most of the times what matters is the time from when the team starts the implementation of a story to when a story is done according to the definition of done of the team.
There is a comment from Joe about that, Mattia, just at the end of the chat, so that's why I'm entering. To some teams, time on backlog is important. If the customer makes a request, the time starts then. So the lead time, blah, 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 blah.
Yeah, fair enough. So yeah, indeed, if that's the sort of prediction that you need to make, then absolutely capture the data from that moment and then use that data to make your predictions to that customer. Bear in mind though that you're going to have a lot more variability in that data. There's going to be a lot more variation because usually stories spend an unpredictable amount of time in the backlog. But that could depend on your context and how you work on your stories, how you prioritize things in your backlog. So yeah, sorry, I guess it depends on your context in this case.
Yeah, in fact, I think that every team could take a decision. The important point is to make a rational decision and be coherent with the decision. So it's up to the team to decide if they want to put the waiting time also in the lead time.
Yeah, indeed. So if you capture both, just make sure that you keep them separate, and then you could always do both predictions at the same time and see what the difference is. Is there any other question that you want to call out?
Well, there is the last one, for example. How could you implement this when you inherit a project? So you are not starting from the beginning. So I think this is the point.
Okay. Well, yeah, it's always challenging to inherit the project from someone else that might have left a mess or whatnot. What I would do is, accept that you are where you are. And then I would usually have a mini re-kickoff of the project with the team and make sure that we know what work is remaining, make sure that we have all the epics and stories that we want for this project. And that gives me an updated scope of the project. Then I would look at if there is any data about this team, if the team has any data about how much they've achieved in the past. I might already have some throughput that I can use, so I can start making predictions. And then at the end of every sprint, I update my forecast again with what the team is achieving.
There is a question, Mattia, from Shai. Stories usually are items of business value. Normally, work consists of different types of items, such as spikes, tasks, and what else. How do you account for this?
Indeed, yes. So what you do there is you treat those things as, in Kanban, we call them different work item types. And what you do is you segment your data by work item type. So if you needed to make a prediction about a story of the first type of story that you mentioned, then you would use data from similar stories in the past. Whereas if you were trying to predict something like a spike, then you would use separate data. Having said that, it's not so common that you need to segment data like this. So what I tend to do, if I think that I need to separate data, I run two forecasts at the same time, one with all the data together and one with the data split into separate types to see if I actually get different results. And more often than not, the results are still the same, so you can actually keep it simple.
Okay, a couple of more questions are coming. How do you apply this technique to larger initiatives that might go for many months? So
yes,
create hundreds of stories up front.
Yes, very good point indeed. So if we are trying to do a forecast for something as big as that, absolutely, we don't want to have to break down all the work up front. That would turn into an anti-pattern. So what I do in that case, well, first of all, if there is an option, I would try to break the project down into smaller milestones and work with something more manageable. But if that's not an option, then what I would do is you get the team to just identify the epics that are required for this long piece of work. And then you break down just a few samples of epics, just a few example epics, And doing that based on how many stories you get from those example epics, you forecast how many stories you're going to have in total. So you're predicting how many stories are going to be part of the project without actually having to break them down.
Okay, good. Then there is a question above saying that did you apply this approach also for non-IT teams such as marketing?
Not personally. No, I've always worked with software development teams, but as long as that team, say a marketing team, has got a workflow that they follow, a process, and they've got some work items that go through this process, then absolutely there's nothing stopping you from writing down the start and end date of one of these work items and applying exactly the same things. You know, these forecasting techniques are quite new to the software development world, but they are well known in other industries. It's how architects forecast how long a building is going to take to be built. They call it reference class forecasting. It's used for predicting earthquakes. It's used for predicting hurricanes. So absolutely, you can apply to all sorts of uncertain events that have nothing to do with IT.
And Mary is asking, what discipline is required by the development team?
Discipline. I'm not sure how to interpret that, but what you need from the development team is not much more on top of what they already do. So the discipline I guess is in trying to be more agile and working with small stories and trying to limit your work in progress. So I think the discipline is more around, just trying to have a good flow. Then the metrics are just something that reflect that flow and how the team is doing.
Yeah, agree. There is a question from Nabil about scaling. So does this apply to multiple teams working on the same product? I would change. If so, how we have to change it?
Well, it can absolutely scale as long as, so in that case, I wouldn't focus so much on the individual teams, but keep the focus on the work item. So we in Kanban, we often say that we focus on the work, not the workers. To scale this up, for example, and I'm trying to do, I've done this at portfolio level, for example. Instead of tracking stories, you would track epics. So you would have some portfolio board with tracking your projects or products and epics that various teams are working on. And you can do exactly the same things by gathering data at epic level instead of story level. And then you scale this up by doing these predictions at portfolio level.
Mm-hmm. And the last that I have, can you use previous experience to give a baseline of could be expected? Well, I think it's exactly this is the idea.
Yes, the answer is yes. It's exactly what I'm advocating for.
Okay, let me scroll. Okay, unfortunately, I don't have the initial questions because when I jump back, I lose the previous chat. But I think that we have given answer to all the questions. So
sorry, there's a clarification from Lisa about her question, I think. So by previous experience, she means data from different projects or teams. That's very interesting. Indeed, that's what I usually do when I have no data. So say that you're starting to work with a new team or it's a team that's just been brought together, or team that doesn't have any previous data. There is no data to use, so what I would do in this case is a couple of things. One is what you say, if possible, I look for similar projects that maybe they've done, or a similar team that has a similar setup, and run my initial forecast using that data. But then I also, in this case, usually just ask the team, what do you feel that you could achieve in a sprint in number of stories? What would be a pessimistic prediction and an optimistic prediction? So I asked the team to tell me what they expect their throughput to be. And I ran a couple of forecasts and use both results together to give me a weak indication of what might happen. I have to stress though that these forecasts run with different data. I don't have high confidence in them, so that they help me at the beginning, but then as soon as I start working with the actual team and I start collecting real data, I replace this fake data with the real data and start doing better forecasts.
Okay, Mattia, I will open the microphone, I think.
Yeah. Yep. Cool.
Okay. Okay, now you are allowed to unmute yourself if you need. Okay, so if you want to say something, unmute your microphone, and Mattia or anyone else can respond. And I've shared the link to the feedback, sharing again. So just click on the link and it takes 2 minutes to give us a feedback.
Hello, Mattia.
Yes, you can.
Okay, I'm just wondering if this technique can be used for critical determinant of a project, and if a team is unable to, for example, estimate effectively, perhaps maybe they are new and they're just starting to get used to way of estimating a story, can you still make use of this technique?
Mattia? Okay, sorry, Mattia, now you can talk.
Oh, okay, sorry. I'll start again then. Yes, you can absolutely use this, because the point is that we don't ask the team to estimate. And this is particularly useful, you know, when you get teams that are new working together, or maybe there are some dysfunctions going on. They might be overconfident in what estimates they do, and they look at a story and say, oh, this is so easy, I'm going to get it done so quickly, and then it takes days and days and days. So using data instead of asking people to estimate really shows when these things are happening, and you get realistic predictions rather than really overconfident estimates. Sometimes these predictions are scary because they show that stories take weeks instead of the days that we estimate. It's the only way that we can take a hard look at what's happening for real and start to do something about that.
Hi, I have a question, by the way. First of all, thank you very much for your presentation. It was really, really interesting.
Thanks.
And actually, it's not the first time I see you. I saw you on YouTube like a few weeks or a few years ago. So I have been implementing, this technique for a few years already. And one of the things that I noticed is in the burn-up, let's say every single burn-up that I've seen in my life has gone through that S shape that you may have seen many times.
Yep.
The thing I noticed is that at the very beginning of the S, of that shape, the data that I was gathering was not, in my experience, was not as useful to forecast compared to the data you start getting once you get to the inflection point. So therefore, let's say what I started to implement a few years back was a way to detect that inflection point. And then once that inflection point is there, a few data points later is when I start basically, implementing the forecasting and start basically providing to senior management, for instance, information about the range of potential dates when things are going to happen. I don't know if that has been your experience as well.
Sometimes, yes, yeah. So it sounds like, you're doing something really clever. This happened to me, especially when a team was new. So you see that the shape of when they start working on something and they're going very slow, and then they become a bit more, they pick up pace, and that pace is sustainable. You could, what you said makes absolute sense. Once you've got data from the, from the team just running at pace, you could discard that early data from the initial part.
Thank you.
There is a related question from Lisa. How do you detect the injection point?
Well, personally, I do that by looking at my data very often. So today I talked mostly about using data to make predictions, but the other side of the coin is that I very often use this data to drive continuous improvement in the team. So we would have retrospectives where we look at our data and discuss how we can improve and what's happening. And so in doing that, we would very quickly see that, usually we range between 8 and 10 stories in a sprint. And the last couple of sprints, we've only hit 4 or 5. So that raises questions and makes me ask, what's going on? Have we got a problem? What can we do to go back to normal? So yeah, the answer to the question, I think, is just regularly looking at the data, and you will see when trends are starting to change.
Hi, Matt, it's Shay. First of all, thanks for your presentation. It's really interesting. There's something
Thanks.
I'm getting into at the moment regarding, been reading up on, I'm trying to get this stuff and all that. So it's really interesting stuff. The question I want to ask is, so this all depends on how soon you can get your team to break down the stories to similar sized items, would you say?
Can you expand on what you mean by
initially? So because if you're using story points, for example, you can, the team will estimate at 1 point, a 2 point, a 3 point, etc. But to get a realistic measurements, obviously it's the throughput of stories at the end of a sprint if you're using sprints. So you've got to get your team to break down the stories to as low as possible. Do you know what I'm trying to say?
Yeah.
Is that the key to getting accurate forecasts?
I would say so, yes. So it's as if you took your planning poker cards and you throw away all the cards except the card number 1. And you're asking the teams to break down stories so that they're all as small as possible. And once you have that, okay, they're not all exactly going to be a 1, but it doesn't matter anymore. They're going to follow a natural variation that is represented in your data. So once you're breaking up stories as small as possible, you can use your data to make predictions.
So, I mean, if a team's new to this, then it's going to be quite difficult. So you're going to have lots of erroneous data at the start. Is that right?
Yeah. A lot of teams struggle with breaking down their stories. They struggle with story slicing and understanding why small stories are better and how to make your stories smaller. But there are a number of techniques out there that can help.
Okay, cool. Thanks a lot.
Sorry, can I ask a question?
Sure.
I'm a bit confused about that. Why do the stories need to be small? Why would that make any difference? Is it just reducing the variability? Is that the reason?
Well, there are many advantages to stories being small that are not necessarily related to using them to make predictions, but just in terms of helping the team be more agile, have better flow. You know, with small stories, you deliver values in smaller chunks, so you deliver them quicker, you get feedback earlier. And in answer to your specific question, I guess, yes, it's the fact that because we're making an effort to breaking them as small as possible, that reduces the variation that you would otherwise have. It would be as if we are comparing, you know, pebbles with stones. If our data has got things of a different order of magnitude in size, then our data is going to have so much variation that our predictions are not going to be very useful.
Great, that's really clear. Thank you.
Thanks.
I guess my only point on that would be, is there not, though, an overhead? Because obviously, you know, if I just can imagine me going to my team and then they're going to say, well, oh God, we've got more tickets now, we've got to manage. And I guess my initial thought is there's a risk there that we've then got a lot of tickets and waiting time potentially. But I guess it's a balance of getting it, you know, not going too small. So
possibly. I guess I would need to know a little bit more about how you manage these tickets. But for me, usually, so some things that helped me in the past with teams doing this is that you wait until quite late in the process to create these tickets. So, you know, it's as part of our workflow that the team is using, there will be a point where the story or some requirements are broken down into stories. And that's right before the team is going to work on those stories. So in leaving that to quite late in the process, then you're only dealing with, you know, a few epics and a few stories at a time. So the overhead can be there a little bit, especially if we use clunky tools like Jira that a lot of us have to use.
okay.
But the benefits usually, are more than that overhead for me.
So can I ask then, if Jira is clunky, what would you use as an alternative?
Okay. I'm gonna go really old school, and I'm still a big fan of. So I usually would, unless I'm in a pandemic, I would coach teams to use a mix of physical boards and electronic tools. So usually I use physical boards as my real view of what's happening, where I can really implement a Kanban process and show what the team is truly working on. And then very often I have to use a Jira instance that I'm not allowed to change and I don't have permission to do the things I need. So I just trick Jira into representing what's happening, and yes, I still create all the tickets there, but then it's on the physical board that I actually represent the real work that is going on.
Okay, so just
but I know that might be unpopular with some people, and that's fine.
I'm just curious to understand, and I know that there are lots of tools out there. Just personally, I found Jira to be extremely configurable, but I do understand that if you're not able to make those changes, then it's going to be challenging. So
yeah. I mean, there's nothing wrong with Jira per se. I mean, there are some really clever people developing that tool, but for reasons I don't quite understand, a lot of companies take the approach that there is one huge Jira instance to be used by thousands of people with one workflow that everyone needs to use, and that just kills agility for the teams.
Thank you.
Thank you. Any more questions? Okay. Good. Raise your hand if you cannot unmute. Okay. Well, Mattia, what can I say? I really love this session. Okay. It's not my first time, and I think it's full of insights. Actually, just for your information, after that I see this the first time, you know, for the Italian group, I start implementing the first graph that you showed. I mean, an analysis on what is the relation between the size as estimation and the time spent to deliver the story. And it was really, really interesting. Actually, it was really, really interesting.
Nice.
I did it using EasyBI, that is the Jira plugin. So I think that most of the worksheet that you have prepared can be done in EasyBI. It will not be easy, but whatever. So just to tell you that in my small environment, we start using this approach to check what we are doing.
Nice.
So I really love it. And many, many thanks for sharing. It's a great talk. I completely agree. And so what can I say? Thanks again for sharing with our community. And I hope to see you soon, physically, in front
at some point,
of
yeah,
a glass of beer in some pub. Okay, Mattia?
Of course.
Thank you all for joining. If you want to say something, please.
No, just thank you everyone for listening and for the great questions. If you got any more feedback or questions from me, these are my contacts. Feel free to get in touch. And either later tonight or tomorrow, I'll put some links on the meetup page to the slides and a few other useful things.
Thank you.
Nice.
Okay, I set the link. I wrote the link for the feedback form in the chat. So I hope that many of you have spent these few minutes. And next event is next week, 14th of April. We talk about psychology in Agile. So I hope to meet you there. Bye-bye. Thank you. Thank you for joining. Thank you for joining.
Bye.
Bye. Thank you.
Bye.
Bye.
Thanks. Bye.
Bye. Thank you.